Okay, so today we are going to start a lecture on K nearest neighbor algorithm. So in statistics, the K nearest neighbor algorithm is a non-parametric supervised learning method, and it was introduced by Evelyn and Joseph in 1951, and it can be used both for classification type problems and regression type problems. So the key characteristics of your KNN algorithm is that it stores all data points, and based on those data points you make predictions for a new data point or a target data points. We can say that it uses the proximity to make classifications or predictions. So what are the steps that are involved to estimate your new data point, class, or your regression value? So the steps that are involved: you have to choose a value of K. This determines the number of nearest neighbors used to make the predictions. Then we have to calculate the distance. So after choosing your K, we calculate the distance between each data point in the training data and the target data point for which prediction is being made. And in order to do that, we use a variety of distance metrics, including Euclidean distance, Manhattan distance, Minkowski distance. We are familiar with this. We studied this in the very beginning of the lectures. So different distance measures can be used. So for example, these are your existing data points and this is your new data point. So considering this data point, we first estimate the value of K. For example, we start with 3. So we are considering only 3 data points that are nearest to this, nearest to this data point, which is the circle. So what are the nearest? For example, these 3 are the nearest neighbors to this data point. And in case of classification, we measure the distance between these 3 data points. Next, if you are done with the distance, we find the K nearest neighbor. So we will find in first all the distances. All these distance values will be calculated using any of the distance measures between the existing data points and the new data points. On using that information, we can finally calculate or estimate the prediction. After finding the neighbors, we calculate the value of the dependent variable for the new data point. For this, we take the average of the target values of the nearest neighbors. So among them, we select the 3 neighbors. First, we calculate the distance with all the data points, and then we find the nearest. And for the classification type problem, we can do the voting. So among these 3, we have 2 x's and 1 square. So the majority vote goes to X. That means this blue data point is actually an X. In case of a regression type problem, we will estimate, for example, this value has the label 6, 6 and 5. So using these three nearest neighbor, we will calculate the average of these values. So for a prediction or regression type problem, we calculate the average. So that becomes 17 by 3. That value will be assigned to this data point. And we have already discussed the voting type, so it belongs to X, and in case of regression we can actually predict a numeric value. So this is your introduction to, a brief introduction to your K nearest neighbor algorithm. We are going to study what is classification with KNN, regression, and then there's some study about variation of KNN algorithm, some of the distance measures that can be utilized to solve such kind of problems. So what is a classification? We have to predict the class of the unknown data. I have already discussed an example. So which class does this new data point or unknown data point belongs to? We have to find the or predict the class. In the KNN algorithm, the hyperparameter K has to be very meticulously selected, because it can alter the decision boundary. A very small value of K could lead to overfitting. We are not considering that many neighbors. We are going to make a decision with a very small number of data points, so we could overfit our results. And in case of a large value of K, it could underfit and the results could not be that accurate. So in case of this, we have three data points, one red and two blue. Among these three nearest neighbors, so if we choose the voting for classification, we can see that this point should belong to the blue class. Remember, it is supervised learning, so we already know the classes. So you can see here, if we are choosing only one neighbor, look at the decision boundary. If we are choosing only one nearest neighbor, it belongs to the red class. However, if we are considering three nearest neighbors to that data point, we can see the decision boundary is changing. So the decision boundary is subjective to how many neighbors we are considering. So it is very sensitive to the number of neighbors we are going to consider. We can see the nearest neighbor, the classification is becoming more and more less conservative, and among 10 we can see the decision boundary is nearly going towards the linear side. So it would underfit the model if we are choosing a very large value of K, and in case of very small value of K, we can see it is going to overfit. It is going to adjust each and every data point. So the other problem, other type of algorithm or the problem domain that we can handle is the regression type. So what is KNN regression? It is type of instance-based learning or non-parametric algorithm. It uses all the training data set, data points to make the predictions. It does not learn a model, unlike we have studied so far. For example, in our CNNs, MLP, RNN, you can see we are trying to train a model, and then based on that we are going to make some predictions. However, in the KNN regression, we do not learn a model. To predict the new values, so it is suitable for online type algorithms. KNN algorithm does not make any assumption about your training data and the relationships within your data. It just finds the nearest neighbors to your target data point and then estimates based on a function. It is very simple and straightforward approach to regression. It can both be used again for regression and classification problems. So we predict the value of dependent variable. So you can see here, this is your independent and this is your dependent variable y. It predicts the value of dependent variable for a data point based on the average or the mean value of the target value of the k nearest neighbors in the training data. The value of k is a user defined hyperparameter and determines the nearest neighbors used to make the predictions. So in this example, we can see here, we have already studied the example like this in our regression type model. For example, if this is your age and then on the y-axis we have your shoe sizes. So as age increases, your shoe size also increases. So for a KNN regression, it is different from the linear regression or the polynomial regression. It does not make any assumptions about your underlying relationship between the features and the target variables. So linear regression, for example, and multiple regression work on the assumption that the dependent variable, this y, dependent variables and the independent variables on the x-axis, they are linearly related. So this is the assumption that we work with. However, the KNN regression algorithm doesn't make any assumption. It relies on the pattern in the data to make the predictions. So in KNN regression, we are relying on the patterns in the data to make predictions. So if you follow this example, we have to make a regression output considering your dependent variable. For example, this is the point and we want to predict what would be the value here. Considering this data and KNN algorithm, we first determine which are the nearest data points to this target data point. So we can see here that these 3 data points are nearest to this data point, considering the progression lines we have shown here. These 3 data points would be the closest. So in the regression, what you actually do is you take the average of these 3 values. You take the average or the mean values and assign to this y variable. As I told you, the selection of this k hyperparameter is very subjective and it will change the decision boundary. So in case if we choose only one for this, one nearest neighbor, for this data point, this will be your decision. However, for this data point, this will be your decision, and based on this we have drawn this regression line. So now we are considering only one neighbor, and we increase the neighbors, we will see the impact. How this changing value of k will affect this regression line that we have, prediction values that we have estimated. So let's find this. If we increase the value and considering 3 nearest neighbors, for this data points we consider the nearest data points to this, and then we draw this estimated line. We can see for this considering only one nearest neighbor, the regression line is different, and we increase the number of neighbors, so the regression values will change. For 5 again the regression line is going to change, and if we consider 10 neighbors, we can see it is becoming nearly linear. So as I told you, if we increase the value of k to very large, it would underfit and the results will not be that accurate. And if we are considering k to be a very small value, in this case 1, again it is going to overfit, and the value that we estimate for x here may not be that accurate prediction. So choosing the k value is important. So we are going to continue with this example of KNN regression.